Okay, so now we are doing the memorization approach or memoization approach. So basically, in the previous recursive approach, uh, we were able to figure out many overlapping cases because it keeps repeating, calling the same step. For example, it would call. For example, if we want to reach the nth step and we are currently at third step, so we would call for fourth step and fifth step. From fourth step we would again call fifth step and sixth step. So basically we are there are overlapping cases. So to assure that there are no such overlapping cases and we don't do extra work, we use memorization approach. So it is just like the recursive approach, but we just have to add the this memorization case, that we are storing the values into a dp array. And if at any point we have something like which is already stored, for example if we have already calculated dp of 4, so we would just use it again whenever dp of 4 is called. So that's why I've written this line. Base case remains the same. Basically, for example, we are allowed to jump one step or jump two step. So again, if we reach here, we can jump from here to here. So we can see that we are just repeating some steps. So that's why we have used this memorization approach. So I would initialize a dp and I would fill -1 as a default value, so that I can compare that if it was already filled or not. If it was uh, if dp of j is not equals to -1, means some value is already there except -1, it means we have already filled this, we have already calculated this. So I would return simply dp of j, and I would not calculate the same thing again for dp of 4. I would not again call the I plus 1 and I plus 2th step. The rest remains the same. For example, for one step movement I would call help j plus 1 and dp, and for the 2th step movement I would call j plus 2 and dp, and I would return o plus t and 1 plus 2 steps, and I would store it in my dp of j. So the time complexity here is o of n plus O of m, which would be the path length basically. And the space complexity, as we are using the recursive approach, so the space complexity is O of stack space, that would be O of n. And we know that we can minimize it further. So that can be done by using the tabulation approach. We would do it in the next segment. Okay.